Okay, so we're going to look at linked lists from scratch. And they may seem scary or frightening at first, and they may well do. So don't feel bad about that. It's just normal to be scared of these things. They're new. They seem very complex. Really, they're quite simple, and I hope to convince you of that by the end of the video. So hopefully by the end of the video you won't be frightened anymore, and you'll think, oh, that was nothing to really worry about at all. That's what I'm hoping anyway. So there's a linked list class included with Java. We're not going to use that. Okay, we're going to develop our own from scratch, from first principles. So we're not going to make use of any special features in Java. We're just going to build our own from scratch. Okay. So before we do, let's just talk about primitive types and reference types. It's important to get this straight in your mind before we move on. So primitive types contain the actual data you want to store, and there's a bunch of these in Java. There's integer types, int, long, short, byte. There's the floating point types, which you can store fractions of numbers as well as whole numbers, and those in Java include floats and doubles. There's the char, which is really an integer type, but it can also store characters, and the Boolean type. They're the main ones in Java for primitive types. Okay, and when you declare an integer like int value, value actually contains the value of the data you're storing, the integer you want to store. Might seem obvious, but that's how they work. Okay, and they're automatically available to every Java program that you write. So there's no need to do any imports or anything like that. They're automatically available. That's primitive types. Okay, now on to reference types. So there's two types of data in Java. There's primitive types and reference types. We're now talking about reference types. And they contain a memory address of where the data is stored. So they don't contain actual data. They contain a memory address of where the data lives. So you've got like this extra hop thing going on. So if you want to get to the data that a reference type is storing, you've got to get to the memory, look up the memory address, and then jump to that location in memory, and then start reading the data from there, or writing the data. Okay, accessing the data. So an extra hop's required to get to the memory address of the actual data. So you might think, well, that means reference types are going to be slower than primitive types, and that's true. Okay, because there's this extra hop involved. So reference types included with Java, apart from the string class, that's automatically available to all classes and all programs in Java. Apart from that one, you need to do an import if you need to use any of the other reference types in your Java programs. An example is date. So if you want to use dates in your program, you have to do an import java util.date. Okay, and there's linked lists and trees and all sorts of things, queues. You need to do an import for every one of those reference types in Java. Okay, so that's the basics. Primitive types, they store the actual data. Reference types, all they contain is a memory address. And the memory address can be anywhere that's valid in memory that's accessible by your program. Okay, so let's look. Okay, so let's say you've got an employee class, and each employee's just got a name. So we're just going to keep it simple. Each employee's got a name. So when I declare employee 1, employee 1 equals new employee, and I might call set name. So emp1.setName Moose. Okay, so employee 1's got a name of Moose. In memory, that looks like this. So employee 1 contains a memory address, and that memory address contains the data for an employee. Okay, the instance data for an employee. So in this case, it's just a name, but it could be ID and start date and all sorts of things, salary and all sorts of things. But we've just got name in this case. So employee 1 contains a memory address, and that memory address has a piece of string data, and that contains the string Moose, and that's Java knows that's the name for the name instance field. Okay. If we declare another employee, employee emp2 equals new employee, emp2.setName to Bella, then we have employee 2 contains a memory address, and at that memory address there's going to be some employee data, and the name's going to be Bella. Okay, so two separate memory locations. emp1 is one location, emp2 is another location. They could be anywhere in memory that's accessible to your Java program. They don't have to be next door to each other, they could be anywhere. Okay, emp1 contains a memory address where there's a string data called name, which has got a value of Moose, and emp2 contains a memory address where there's some string data called name with a value of Bella. Now if I do this, emp1 equals emp2, okay, I'm not copying the data, okay, I'm copying the memory address. I'm saying emp1 equals the memory address of emp2, because they're reference types, they're not primitive types, they're reference types. Okay, so emp1 and emp2 both contain memory addresses. So when I say emp1 equals emp2, employee 1 and employee 2 now contain the same memory address. So in memory it looks like this. They're both pointing to the same employee. Okay, and that's the one that employee 2 points to, because I've said emp1 equals emp2. So emp1 now contains a memory address of emp2. Okay, they're both referring to Bella. No one is referring to Moose anymore. No one's referring to him, and Java's garbage collector will clean up that piece of data when it gets around to it. Okay, so emp1 and emp2 are now both referring to Bella. Okay, so if I say emp1.setName to Frankie, and then I go system out print line emp2.getName, so I'm setting employee 1's name, and I'm going emp2.getName, then that's going to change this to Frankie. emp1 set name to Frankie is going to change this to Frankie, so Bella will now be Frankie, and emp2.getName will get the name of this employee, which will now be Frankie. Okay, so they're both referring to the same memory location, the same employee in memory, and any changes to that employee affects both of those objects. So this one and this one are both referring to the same location in memory. So if I change anything with emp1, that's reflected in emp2 because they're both referring to the same location in memory. Okay. If we have a look at the code, so here's the code here for that exact example. So I've got an employee class, just one piece of data, a name, a default constructor that just initializes it to space blank, a getName method which returns the name, and a setName method that sets the name equal to the value passed in. So just a simple little class, about the simplest class you can have in Java. And then a tester is just the code we just looked at. So employee emp1, set name to Moose, employee emp2, set name to Bella, emp1 equals emp2, emp1 set name to Frankie, and I'll go emp2.getName, and that should be Frankie as well. And that's certainly what we get when we run it. And there it is, Frankie on the screen. Okay, so that's that in practice. Okay, so that I'll include that code there with a linked list, some Scratch code in my GitHub, so it's there for you if you want to run it and play with it. Okay, it's just a simple little class with a simple little tester. Okay, so once you understand that reference types have the memory address, and the memory address contains the data for whatever the data type is. If it's employees, it contains the employee data. If it's a reference type of string, it contains the string data. If it's a reference type of date, it contains the date data, and so on. Then you're ready to go with linked lists. Okay, so what we might do is create all linked lists are based on a node. Okay, so we'll create a node class, node, and this node could contain anything. Okay, it could contain just a simple string. Okay, or it could contain an array of names, or it could create an array of images or videos or sounds or everything. It could contain multiple pieces of data as well, so it could have and so on. So you could have all sorts of data in there, and each of those could be arrays. It could be an array of names, an array of ints, an array of dates. Okay, so you could have many types of data in there. You could have arrays of linked lists. You could have anything. So for this example, we're just going to have a single name, but just keep in mind that each node that we have could contain any data we like. Okay, so each node has got a name, and we'll have a getName and a setName method, like we have over here. We'll just copy this code basically. Okay, so and it's the node. So when we create a node, we'll set name to blank. We've got a getName method and a setName method, and we've got to move that curly bracket down there. Okay, so that's the end of our node class. I'll do everything into one file to keep it simple, so I'm not changing around between files. Okay, and then we've got our linked list from Scratch class down below. So our node class is pretty well just what the employee class was, just renamed a node. And so now we're going to work with that down here. Public static void main. The usual main for a Java program. And what we want to do is create a node. And we might actually change our constructor a bit, just so we don't have to keep calling setName, setName, setName. Okay, so we might actually change our constructor so we have a default, a parameterized constructor as well. And that'll take in a string, and it will set name equal to whatever's passed in. Okay, so we've got a default constructor, and now we've got a parameterized one as well. Okay, just add a little bit in, just so we don't have to call setName, setName, setName all the time. Just make our main program or our tester class a little bit simpler. Okay, we could have done that with employee as well. I want to keep the code really short. Okay, but so now we've got this default constructor. Let's use them. So we want to declare a node. Node A is equal to new node. I'll call it node 1. And we'll give node 1 the name Moose, just for fun. And we'll declare another node, node 2. And we'll give that the name Bella. And we'll get a node 3. And we'll give that the name Frankie. So here we've got 3 nodes in memory. Just like we had 3 employees, node 1 refers to a location in memory where there's a node data, and that's got a name with a string value of Moose. Node 2 contains a memory address of a location in memory where there's node data, and that's got a name with a string value of Bella. And node 3 has a memory address of a node in memory, and that's got a name with a string value of Frankie. Okay, so picture those boxes we had for employee, emp1 and emp2. Got similar sort of setup for node 1, node 2, node 3. Okay, so now, not much good so far. We've got three separate pieces of data in memory. We can't move between them very easily. We certainly can't traverse the data. So we need to add a little bit more in. Okay, so what we might do up here is change our node class slightly, and we're going to make it a self-referential class. Private node nextNode. Okay, so inside our node class, we've got some node data, and it contains a nextNode. Okay, so it's a self-referential class now because we've got some data inside our class, which is of the type of our class. Okay, so self-referential class, and this nextNode is the chap we're going to use to move between nodes. This is what's going to make it a linked list. Okay, so in fact, let's draw what we've got so far. So we've got node 1, node 2, node 3, and I'll go back to the prior slide and I'll grab these to save me drawing them. So, and back one more, and we'll get, okay, node 3 contains Frankie. Okay, so that's what we've got so far. Just 3 nodes in memory. Each contains a memory address, and that would be lowercase, of course, because if we're going to be really serious about it, because we've got no lowercase in our program. Okay, so there's our 3 nodes, and that's what it looks like if we drew it as to how it looks in memory. Okay, so they're not joined together. So when we add this next node here, we've got something else. Every one of these bits of data now, or every one of these node classes contains a nextNode field. And for now it's null. nextNode. Okay, because we haven't set it to anything, by default Java initializes the reference types to null. So we've added on a nextNode to our class here, but we don't use it anywhere. It's not being referenced, so Java automatically initializes it to null for us. And in fact, we can do that in our constructor. nextNode equals null, just to make sure. Okay. So we've got our 3 nodes, and we've got Moose, Bella, and Frankie in the data, in the string data for names, but our nextNode still isn't being used, so it's got a value of null for each one. let's add a new method in. Public void set next node. So what we want to do now is be able to set this value, next node. So we're going to take in a node, piece of data, and what we're going to do is say next node is equal to n. Oops, sorry, wrong place. Sorry, I went cross-eyed there when I was writing the code. Sorry. Should be inside our node class. Next node is equal to n. Okay, so we've added a setNextNode method. It takes in a node piece of data. Okay, anything of type node, which is our class here, node, and it sets the next node, which is our private class data item, this chap here. It sets our next node equal to the value of the node passed in, or the value of the node passed in. Okay, so we're doing that thing where name one, employee 1 and employee 2, we're going to make it so employee 1 can refer to employee 2, that sort of thing. Okay. Okay, so I'll get rid of that extra brackets that I put in there by mistake. Okay, so now we've got this setNextNode method. Let's use it. Okay, so the next node to node 2, or node 1, we'll make it so the first node's node 1, and node 1's next node is node 2, and node 2's next node is node 3. Okay, so we just linked them up. So if we have a look at our diagram again, node 1.setNextNode to node 2 has done this. Node 2. Okay, so node 1's next node is now node 2. Okay, and node 2 setNextNode to node 3 has done this. Node 2's next node is now node 3. Okay, so it's filled in some bits of data here. Node 1's next node is now node 2, and node 2's next node is now node 3. So this is a memory address of node 2, and this is a memory address of node 3. Okay, we're almost there. We're almost at the stage where we can traverse the nodes. Need one more method up here, and that's public node get next node. Okay, so we're going to have this class tell us what our next node is. So it's just going to return next node. It's just an accessor method. It's just returning the value of next node. Okay, so next node is of type node, so the method's got to be returning a node, and get next node is just returning the value of our next node data item, which is our data item up here, this chap. Okay, so we've now got code to set it and get it. Okay, so we're now at the stage where we can traverse our list. Let's set the current node. Node current node is equal to node 1, while current node is not equal to null. We want a system.out.println. We want to get the current node .getName. Okay, so set current node, create a new node called current node, and set it to node 1. And while current node's not equal to null, we want to display the name at the current node, and then we want to move on to the next node. Current node is equal to current node dot get next node. Okay, so we'll start off at node 1, and we'll get node 1's name, and then we'll say current node equals node 1 get next node. Okay, and that's node 2. So current node is now node 2. So we'll go up here, current node's not null, it's node 2, it's not null. We'll get node 2's name, okay, which will be Bella. And then we'll go current node equals node 2 dot get next node. And node 2's next node is node 3. Okay, so current node is now node 3. We'll loop through, current node's not null, because node 3 is not null, and we'll get the node 3's name, which is Frankie. And now our next node is null. So current node equals node 3.getNextNode will return a null, and our loop will exit. So current node's now null. So this code here is traversing our linked list. We've got a list of nodes. Here they weren't linked together. This is linking them together. And here we're traversing the list. We're starting at the first node and we're working our way through using the next node in our class to find out what the next node is and move to that next node. Okay, so we should see on screen now Moose, Bella, Frankie. We should be starting at node 1 and displaying the names, because that's all we're displaying here, current node.get name. So we're displaying the names of each node. And we're starting at node 1 and going through to node 3. So we should see Moose, Bella, Frankie on the screen. Let's run that. And that's just what we see, Moose, Bella, Frankie. Okay, so that's all a linked list is just a list of nodes or a list of classes where each class object knows about the next object in the list. Okay, it knows the location of it, the memory address. Okay, and so you can jump between them. Okay, so let's now add another node. So up here we'll add node 4, and that's going to be Samuel, and we'll have node 3 set next node to node 4. Okay, and let's update our diagram to show that. So we created a new node called node 4, okay, with the name of Samuel. Okay, and we said node 3 set next node to node 4. So we also changed that there. Node 3's next node is now node 4. Okay, so now we should see Moose, Bella, Frankie, Samuel on the screen. We should see all 4 because we're traversing all 4. We had all the 4 nodes there, and then we linked them all together so that there's one after the other, and our loop should now display Moose, Bella, Frankie, Samuel. Let's run that and see. And there we are, Moose, Bella, Frankie, Samuel. Okay, so that's all the linked list is. It's just bits of data, and each bit of data knows about the next bit of data in the list. It's not like an array where they're next door to each other, adjacent or concurrent in memory, or these nodes could be anywhere in memory. Okay, and by calling setNextNode, node 1 knows about node 2's location, and node 2 setNextNode to node 3. Node 2 knows about node 3's location, and so on. Okay, let's now have it so we have. We'll put a new node inside. So we want to put it. We want to insert a new node somewhere. We'll insert it between node 2 and node 3, just so it's not the start or the end. Okay, so we'll insert a new node here, and we'll call it node 2A. And it's going to go in between here. We'll get those out of the way. Okay, let's draw the diagram first. So we'll create a node. We'll make a node 5. Doesn't matter. The nodes don't have to be numeric. The number here doesn't mean anything. Node 5, and we'll give it a name of Hank, and we'll leave that null for now. So we'll create a new node, and it's going to have a name value of Hank. Okay, let's do that. Node 5, Hank. Okay, back to our diagram. So that's what we've done. So we created node 5. I've just put it in the middle here just so you can see them in order in our diagram here. But you can create them anywhere. Like this order here doesn't matter, and this order here doesn't matter. It's just whatever you set them to. Okay, so we're going to use node 5, and it's got a name value of Hank. So we've created that. That's what we've just done. That bit of code there we've just done. Now we want to make it so our next node, node 5, our next node for node 5 is node 3. node 5 dot setNextNode to node 3. Okay, so we've now changed that to node 3. Okay, but we also want to change this node here. We want to change node 2's next node to node 5. Okay, so node 2, setNextNode to node 5. So just change that 3 to a 5 there. Okay, now node 1 knows about node 2, node 2 knows about node 3, oh, node 5, sorry, should be node 5. Okay, node 5 knows about node 3, and node 3 knows about node 4. And node 4 is the end of the chain. Okay, maybe I could give these better names. It gets a little bit confusing when you're doing numbers here and they're not consecutive, but it's just whatever you set the node to. Okay, whatever you call set next node for. It doesn't matter if they're in order or out of order. It doesn't matter. Okay, so now on screen we've linked all these nodes together, these 5 nodes. So we should see Moose, Bella, Hank, Frankie, Samuel. Moose, Bella, Hank, Frankie, Samuel. And that's just what we predicted. I'll shrink that down a bit. Okay, so current node's pointing to node 1 at the start. And then we move on to node, so that's going to display Moose. Then we move on to node 2. Then that's going to display Bella when we say get name. And then that knows about node 5. Node 5 is the next node. Okay, and that's going to display Hank. And then node 5 knows about node 3, so that's going to be the next node, and that's going to display Frankie, and next node knows about node 4, and that's going to display Samuel, and the next node is null, so a loop will exit. So we see Moose, Bella, Hank, Frankie, Samuel on the screen. Okay, so that's basically what a linked list is. It's just a list of data nodes, and each one of them knows about the next node in the list. Okay, now there is an extension of this, and as well as knowing about the next node, you can also store the prior node. Prior node. So we'd have a set prior node and a get prior node method down here. Okay, and in our main we'd also set the prior node. So as well as calling set node, we'd set the prior node. So node 1 set next node to node 2. We'd also have to say node 2 set prior node to node 1. Okay, so you have to do set prior nodes as well as set next nodes for each node. And then we can move forwards and backwards through the list. We could start at the end and move backwards through the list, or we could start at the front and move forwards through the list. Okay, so that gives you a doubly linked list. When you can move backwards and forwards through the list, each direction, then you've got a doubly linked list. Okay, until we added this in. And the set methods, set prior node and get prior node, we had a singly linked list. You could only move forwards through the list. You couldn't move backwards. Okay, so with a little bit of work there, we can make it a doubly linked list. Just adding that prior node in, and a set prior node and a get prior node, and for each node we've created, also call set prior node, and set the jumpers up correctly, and then we've got a doubly linked list. So it's not hard to do. And then we could start at node 5 and move backwards through the list by calling get prior node. In fact, let's do it. I'll show you how it works. Okay, so we add a prior node in. We've got, I'll just copy and paste these two, Control C, Control V. So we've got set prior node, and that's going to be prior node, and get prior node, and get prior node. Okay, so I just copied and pasted those two set next node, get next node methods, and I've changed them to set prior node to work with prior node, and get prior node to return prior node. Okay, so not a big change there. Down here with our linkages, I'll copy and paste. I'll copy and paste those for now, and it's set prior node. So node 5's prior node, sorry, let's just have a look at their wide up. Node 2's prior node is node 1. Node 5's prior node is node 2. Node 4's prior node is node 3. Node 4's prior node is node 3. Okay, and node 3's prior node is node 5. Is that right? Did I mark that up then? No, that's right. So node 3's prior node is node 5. Okay. So now we could say, so we can still move through it. Let's just make sure our code still works for moving through the list, traversing it forwards. Moose Bella Hank Frankie Samuel. And I'll put a little comment there. We're doing a forward traversal. Going through it forwards. Let's now do a backwards traversal. Backwards traversal. So no current node. We're going to start with our last node in the list, which is our node 4. Node 4 is the end of the list, and we want to move backwards through this by using our prior node. Let's put the prior nodes in. Okay, it's got a little bit of overlap there. It's there we go. It's not too bad. It's only a quick PowerPoint diagram. Okay. So let's just fill in our prior nodes before we move on. So node 2's prior node is node 1. 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 Node 5's prior node is node 2. Node 5's prior node is node 2. So I'm filling in the diagram exactly what I've got written over here. Node 5's prior node is node 2. Node 5 prior node is node 2. Node 4's prior node is node 3. Node 4's prior node is node 3. Node 4's prior node is node 3. Is it prior node to node 3? So node 4's prior node is node 3. And then node 3's prior node is node 5. Node 3's prior node is node 5. Okay. And the other thing you want to do, just make sure you've got a nice clean start, is you want to also initialize your prior node. Prior node is equal to null. So when you create a node, and we should do the same thing here in our parameterized constructor. So we're initializing our node instance fields. In our default constructor, we're initializing them to null, and in our parameterized constructor, we're initializing them to null. You might be thinking that code there looks pretty similar. This code here looks pretty similar to that. Is there a way we can reuse it? And we can, so I'll do that now as well. I'll show you that little shortcut. So we're calling our constructor that takes in a string, and we're just going to pass in a blank string. Okay, so instead of having those 3 lines of code there, we've got 1. And shouldn't matter where it is. I'll leave those there for now. Okay, so we're calling our constructor that takes in a single string. So Java looks through and finds this constructor, takes a single string, sets the name equal to whatever's passed in, which is just blank, and sets the current node and next node to nulls. So that just saves us duplicating the same code here. Same sort of code here in multiple places. Little shortcut. Okay, so we've got the forward nodes, the forward links wide up, and we've got the prior links wide up. We're now ready to traverse our list backwards. Okay, so current node equals the last one in our list, which is node 4. Node 4 is our last node. That's the one that has the null as the next node. Node 4. While current node, node is not equal to null. Same sort of code as above. We'll copy and paste it. In fact, I might. We're going to display the name of that node and then get the prior node. Okay, so it's the same sort of code, but this one's going forward, so it's getting the next node. This one's going backwards, starting at the end of the list and going backwards, so we're getting the prior node. Okay, so what we should see on screen, we're starting at the end of the list, so we should see Samuel, then Frankie, then Hank, then Bella, then Moose. Okay, we're just going to the prior node. So prior node for node 3, prior node for node 4 is node 3, so we should see Frankie, and then the prior node for this one's node 5, which is Hank. The prior node for this one's node 2, so we should see Bella, and the prior node for this one's node 1, so we should see Moose, and the prior node for that one is null, because we didn't set it. So it's still with the original value as the constructor created it. Okay. Current node, double R, and there's our code here. So we traverse forwards, Moose, Bella, Hank, Frankie, Samuel, and then we traverse backwards, Samuel, Frankie, Hank, Bella, Moose. Okay, so we've pretty well built our own linked list class from scratch. We can traverse forwards, we can traverse backwards. With a little bit of extra work, we could make it generic so it could store any type of data. Okay, and what we want to do next is make it so whoever's using our classes doesn't have to do this sort of thing. We want to make it so it's done automatically. So we want to have we create our own class with add nextNode and so on. And shall we do that? Yeah, so that's what we'll do in our next video, in part 2. So we'll create it so we don't have to worry about creating each node and then doing the plumbing manually in code. We'll make it so our class, our linked list class, can take care of it all for us. We just add a bit of string data to the linked list, and it takes care of all the plumbing, setting up all the linkages. Okay, so that's something we'll do in part 2. Okay, hope that was useful. Thanks for watching.